also want to confirm if everyone is hearing me clearly. Okay, thank you so much. I want to welcome everyone to my lecture today. And of course, today I'm going to walk you through an exciting topic in statistics. And of course, in today's work, we basically going to be visiting courts. Okay, you are actually going to walk you through how statistics can actually be applied in litigation. Okay, give me 1 second. I'm actually going to share my lecture slide. Okay, so the focus today, like I said, we actually be on the Bayes theorem in the courtroom. And of course, Bayes theorem is one of the technique that we use in statistics. You remember in the last class, I actually introduced us to probability. I walk you through some basic fundamentals in probability. And of course, I also walk you through what I call the views of probability. And today, we're basically going to be visiting the courts, and I'm actually going to be walking you through how statistics can be applied. And that was why, and what we're going to be using is what we call the Bayes theorem. And the question now is, can statistics help guide a verdict in a courtroom? Now, let me tell you this, why do we actually think about using statistical idea in the courtroom? You remember I told you the other time, the only certainty you get going to court is actually uncertainty. And of course, you know, you don't, if you have a case in court, you don't have 100% chance of winning. I'm going to say none of both party actually that are involved in the litigation has 100% chance of winning. I think I mentioned the reason for that. Number one reason is that none of them is 100% perfect. And not only that, the judge is actually not 100% perfect and infallible. And of course, because of that, we actually came to conclusion that you don't have 100% chance of winning a case in court, even though you have, an intimidating evidence. Okay, so because I want to walk you through how to use Bayes theorem in the courtroom. In the outline, I need to first walk you through some basic fundamentals. But before I go into the basic fundamentals, maybe we have a question like this, which is, there's a jury trial, and in a jury trial, suppose the probability that the defendant is convicted or given guilt is 0.95, and the probability that the defendant is acquitted given innocence is 0.95. Okay, suppose that 90% of all defendants are truly are guilty. Okay, find the probability the defendant was actually innocent or given the defendant is convicted. Now, let me tell you, the idea of Bayes rule, we actually be applied here. But before I go into solving this problem, what I'm actually going to do is to walk you through, the basic fundamentals of conditional probability and Bayes theorem. And that's why in the outline today, I'm actually going to walk you through what we call conditional probability. Then I'm also going to walk you through the law of total probability and Bayes rule. You remember when I was talking about the views of probability the other time, I walked you through what we call the objective view in probability and, the subjective view. And of course, the objective view, we actually use the frequency of occurrence of an event. Okay, you remember in class that I discussed something like that. But let me tell you this: if probabilities cannot be determined objectively as a frequency of occurrence, okay, within a defined population, then they actually become what I call subjective interpretation, okay, of a degree of belief. I'm going to say that again. If probabilities cannot be determined objectively as a frequency of occurrence within a defined population, they actually become the subjective interpretation of a degree of belief. And of course, today's work we centered on conditional, probability, because we don't just want to base things on the frequency of the occurrence alone, but we also want to put into consideration, the fact that event could actually, occurrence of an event could actually depends on the occurrence of a given event. So I'll first go mathematical. Okay, I'm going to walk you through this concept before I answer the question about jury and uh, you know and before successfully applying that in the court of law. Okay, so when we're talking about conditional probability, okay, we actually use the idea of conditional events. If I have if I have conditional event, maybe for the occurrence of B, A must have occurred. You can use an example of, okay, what is the probability that I'm actually, like you are taking my course now. What is the probability that you're actually going to pass excellently? Okay, the probability you're going to pass excellently may be depending on uh, whether you attend lectures and some other stuff. Okay, so mathematically speaking, okay, the probability of B given A, this is the way we actually phrase that in statistical analysis. We actually depict, the probability of the occurrence of B given A as this. And you know what? That is equal to the ratio of the probability of the joint occurrence of event to the probability of A. Okay, I wanted to take note of that. So this is a mathematical definition or statistical representation of the probability of B given A. Okay, so what I'm trying to say here, because I'm referring to the probability of the joint occurrence, okay, we can actually use and, okay, if you take a look at the interception here, okay, it's actually means and, okay, we're trying to talk about A and B, okay, the occurrence of A and B, you get what I mean? Okay, so uh, before I go on, is there anyone who need clarification on what I've explained right now? Okay, guys are good, right? Okay, good job. So I'm gonna go to the next slide. Now, I think I've given you the formula for figuring out the probability of an event given another event. But what I want to walk you through now is what we call the law of total probability and Bayes rule. In Bayes rule, we actually use the law of total probability. Of course, the the Bayes rule is basically going to be a ratio, and of course, in that ratio, the will occupy the bottom position of the ratio is a law of total probability. Okay, so what I want to do now, I actually want to go into the metamorphosis of this rule. Okay, so let me tell you this. When you are going subjective, okay, I made a statement the other time that if probability cannot be determined objectively as a frequency of occurrence within a defined from population, they actually become the subjective interpretation of a degree of belief. Now, the idea behind the Bayes rule, okay, was actually given by Reverend Thomas Bayes, a mathematician, who actually partitioned the sample space, okay, of events into various components, as you can see here. We have S equal to A1 union A2 up to union A, and the S is the sample space. You remember in the last class, I actually said the sample space is a collection of possibility. You get what I mean? Before you can actually calculate your probability, you need to have a sample space. And of course, I give an example here. If you are playing with a die, there's six size in the die, because the sample space basically going to be 106. Okay, so if I have a sample space and I partition that into n mutually numbers of events, take a look at that. Okay, and I'm interested in figuring out event B. And that very event B, okay, we actually will be common to the components of the sample space. That's why I'm actually, if you take a look at the Venn diagram I'm actually using here, we have a sample space that is partitioned into even A1, A2, A3, up to AN. And you know what? B is actually at the point of intersection of all of that. So that's why if you take a look at what I have here, B equal A1 intersection B, union A2 intersection B, union A3 intersection B, and so on like that until you get to AN intersection B. And of course, if I have a B as an event and I actually want to figure out the probability of B, okay, what I'm actually going to do, if events are mutually exclusive, if I want to figure out the probability associated with that, what I'm basically going to do is to add them up. Okay, you remember the other time when I was walking you through mutually exclusive event, I said if I have event A and B, is what I actually said, the probability of A union B is basically going to be probability of A plus probability of B. And, you know, I remember I said the mutually exclusive actually attract what I call addition rule. Okay, so if you take a look at this guy now, since this guy is actually mutually exclusive with the other one, and I introduce probability, I'm actually going to add them up. Okay, so when you add them up, okay, so when you take a look at this guy here, okay, it's the same thing as this. Don't forget, you know, when I was defining the probability of B, okay, given A the other time, okay, so what happened? And I actually said the probability of B given A, I said is going to be the probability of the joint, right? The joints A and B, okay? That's the intersection B divided by the probability of A, right? And of course, if I want to figure this guy out, it means I'm actually going to multiply this guy. And that is the reason why I'm actually writing the probability of the joint in this form. Okay, if I actually do that across, okay, I'm actually going to have up to this guy. And when I have that, that actually become the total probability. I'm going to say that again. That become the total probability. Until you get that. Okay, so if that becomes the total probability now, okay, and that is why we basically going to have this guy here. And you know, another way to write this, I can actually write this guy in a short form. They can actually write summation, um maybe the probability of AI, okay, the probability of AI, okay, that the probability of B, okay, given AI, okay, so where I actually start from 1, okay, to n, okay, so this is what I actually call, okay, the total probability, okay, writing that in short form. That is exactly what I have. Okay, so if I have that now, okay, and I actually want to define a base rule, okay, if I want to define base rule, The idea suggested by Reverend Thomas Bay, 1759, is trying to tell us, okay, you know what, if you want to figure out the probability of an event, so what you basically need to do, you need to identify your prior. Okay, that's a prior, right? Okay, this prior is actually what we use in the frequencies approach, where we base the decision on the frequency of occurrence, okay, of events. But what Reverend Thomas Bay is actually trying to tell us now, if we collect our data set, we're basically going to update that. Okay, so because of that, we actually gonna call this guy, the probability of being given AI is going to be called the likelihood. Okay, maybe the likelihood what I actually observe from data set. You get what I mean? Okay, and the probability of AI given B is basically going to be called posterior. Okay, the posterior, the idea behind the posterior now is just, okay, the probability of the state of nature, after updating our prior knowledge, which is basically going to be a combination of the prior and the likelihood. And of course, if I want to define my posterior now, okay, in the context of what I'm actually talking about, okay, if I actually want to define my prior now, so what I'm actually going to do, okay, I'm actually going to start using this, okay, this is the probability of AI given B. I call this posterior. And of course, this guy can be written as this. I think I showed you before. And you know what? This guy is a total probability, which is what I wrote before. And of course, the whole of this guy now is actually what I call, the Bayes rule, okay, which I want you to understand. Okay, now, if you understand that now, I want to apply this in the court of law now, and I wanted to see the way this is basically going to be applied. Okay, now let's take a look at this. Let's say A here, okay, is a probability, okay, that's an accused person uh, is actually guilty, okay, and B here is the evidence, okay, the evidence provided, okay, by the prosecution. You get what I mean? Okay, we want to figure out what is the probability that an accused person is actually guilty, okay, given the evidence. Okay, now this is what this guy is actually saying. But you know what this guy is saying? This guy is actually talking about the prior probability, in the court of law. They also look at, before they collect data at all, they want to look at the history. Okay, does he have a criminal history or something? Okay, that is the probability of AI, which actually represent the prior. But when you take a look at this guy here, it's just going to be, okay, uh, if this guy is guilty, what is the probability, okay, that evidence exists? If a court actually pronounce this guy guilty, okay, what is the probability that evidence exists? I'm going to tell you this guy is not the same as this guy. Take a look at that. They are not the same. The first guy here, this guy here, that I call posterior, is actually talking about the probability, okay, of an accused person, okay, being guilty, giving evidence, okay. They've seen evidence and they found it guilty. But this guy here is basically talking about, okay, what is the probability, okay, given that he's guilty, okay, they find the evidence. You get what I mean? They are not the same. And this guy here is going to be the total probability. So which means the probability of B here is the same thing as the probability that they found the evidence. And if they want to find the evidence, there's possibility, they found the evidence, given that the guy is guilty, and they may find the evidence given that the guy is innocent. That's possible. And that's why it's going to be a total probability. Okay, so I'm basically going to go into, I think, more application now. Give me 1 second. Now I'm going to go into more application now. Something happened in June 13, 1994. Okay, two dead bodies were actually found, okay, in the vicinity of O.J. Thompson, okay, in Los Angeles, in the state of California, in the United States. Okay, so of course the name, the dead body is actually uh, was actually found to be, uh, you know, Simpson ex-wife and his friend. Okay, the name of the Simpson wives was actually Brown, and the name of his friend was Goodman. Okay, was Goodman. Okay, now on these two bodies, they were stabbed so many times. Okay, and you know why is it that the Simpson was actually alleged? Because the prosecution found some evidences. Okay, number one evidence they found, okay, they found that a bloody glove have the traces of Simpson, Brown's, and Godman's DNA. Okay, and that was actually buried in Simpson backyard. Okay, the DNA of three of them, the DNA of Simpson and the two dead bodies. Another evidence found was actually, you know, the blood of Simpson was found in multiple locations, within the crime scene. Okay, another evidence that actually pointed Simpson to the crime, was that they look at the vehicle, of Simpson called the Ford Bronco. Okay, the DNA of the blood stain found on that car actually matches that of Simpson and the two dead bodies. And lastly, in the bedroom of Simpson, they actually find a bloody sock, okay? And this bloody sock actually matched the DNA of Simpson and his ex-wife. Okay, so these are evidences actually, presented by prosecution. Okay, it was a case between the peoples of, uh, state of California, versus O.J. Simpson. Okay, it was a popular case at that time. Okay. Okay. So, in addition to the evidences, looking into the record, they found that, you know, the citizen had a history of domestic violence with his marriage to Brown. Don't forget, the Brown was actually his ex-wife. And of course, it was also reported that Simpson became jealous of Godman. Don't forget the Godman. The Godman was actually his friend. You get what I mean? And because of this, the prosecution actually presented evidence, and they believe the state of California actually have a good case against Simpson. What I told you in the last class that uh, I told you in the last class that none of the litigants, or let me just say, none of those that are involved in litigation is 100% uh, accurate. Okay, and the probability of getting justice, or of winning the case in the court of law is actually, you don't have 100% chance. Nobody has 100% chance of winning. Okay, so looking into this now, okay, uh, you know, I'm going to tell you, despite this evidence, presented by the prosecution um, in October 3, 1995, uh, this guy Simpson was actually the charge unacquitted. Okay, it was the charge. That was why it was the charge unacquitted. Okay, and you know, I'm actually going to let you know the reason why it was the charge on unacquitted, because Professor Paul Taggart, a professor of philosophy at the University of Waterloo in Ontario, Canada, actually explained, he actually gives four competing explanation for the jury's ruling in favor of Simpson. And you know what? One of them was actually, you know, was based on a probability theory calculated by Bayes' theorem. Okay, I'm actually gonna walk you through something now. You know, this is it. Uh, the Simpson Anthony, which happened to be defense counsel at that time, also they said uh, that in their defense they said it was you know the drug dealers that actually killed Brown, okay, because of the fact that he had been known to use cocaine, okay, and of course, the defense also pointed out some irregularity in some evidence, evidence, presented by prosecution at that time. And don't forget, part of the prosecution is the Los Angeles Police Department, because that happens in the territorial jurisdiction for that case was Los Angeles, because it happens in Los Angeles in the state of California. Okay, so, and as a result of that, they believe that maybe the LAPD, the Los Angeles Police Department, actually planted those evidences. And let me tell you this. The situation is this. If I actually want to figure this out, okay, if I want to figure this out, if I want to use what I call the Bayes theorem, okay, I actually want to find the probability of, that Simpson is guilty. Let's say A should represent defend that is guilty, okay, giving evidence, okay. E is the evidence, okay, by using Bayes theorem now, okay, I'm actually going to write, I need to find the probability of evidence, okay, when given that he was found guilty, then I also need to find the probability that he was actually found guilty. Okay, the probability that he was found guilty here, this guy here, is a prior probability, which means even before citing the evidence, you get what I mean? And this guy here is going to be divided by the probability of evidence. Okay, now the probability of evidence will actually going to be a total probability, because why? When evidence is found on a crime scene, okay, in a crime scene, maybe a DNA that matches some accused person, well, what Simpson was actually found, and the probability of the evidence is just going to be it's going to be a total probability, so it's going to be this guy, given this guy, okay, plus the probability of this guy, plus, okay, the probability of the evidence, okay, given you know not guilty, not guilty is actually the complement of that, right? Okay, multiply by the probability of that is not guilty. Okay, so this guy here is what we actually call the total probability. But let me tell you this, it's just like what I said the other time, okay, that if probability cannot be determined objectively, okay, as frequency of occurrence, within a defined population, they become the subjective interpretation of a degree of belief. Okay, I wanted to take notes of that. So, which means, using the idea of the Bayesian inference now, they actually constructed something. I'm going to show you what they constructed before they had these results. They have a Bayesian network. Okay, the Bayesian network, I wanted to see this guy here. This is a network that actually depicts the whole scenario. Okay, if you take a look at this guy, the Simpson was abusive. We part of the evidence presented by the prosecution is that he has a domestic abuse history. Okay, when he was actually with his wife. Okay, and of course that could, the Simpson K Brown, okay, could depend on that. You get what I mean? And Simpson beat, somebody who have a domestic abuse on his wife, so it means he beat his wife. You get what I mean? So take a look at that. So this guy is depending on that. And when you take a look at the kill, if Simpson actually killed Brown, which happens to be his wife, then he could as well kill Goodman. You get what I mean? He could as well kill both of them. And if you take a look at this, when this happened, okay, you're actually going to have the sock will be bloody. Okay, there's going to be blood stain in his car. There's going to be, the glove that was found buried in his backyard will also be bloody. You get what I mean? And there's going to be blood at the crime scene. Okay, you're only going to have all this guy. Okay, if this actually happened, you get what I mean? And of course, if the foreman actually lied, okay, or the EDTA and SOC, okay, and that actually pointed to the LAPD that might have framed up Simpson. Don't forget that was one of the submission of the defense counsel, okay, and if according to the defense counsel as well, they also said what killed Brown, which is Simpson's wife, could be drug related. You get what I mean? Okay, we could as well, kill the two of them. Okay, you get what I mean? So, in the end, you may be surprised. Why is it that they took a decision of acquitting Simpson? Because, despite those evidences, people in Los Angeles in the state of California believe at that time with the evidence, you know, uh, presented by the prosecution, of course, Simpson, we actually, will be found guilty. But I'm going to tell you, it was discharged and acquitted, okay, on October 3, 1994. Okay, now this is what happened when they computed the Bayes theorem. They found, using the Bayes theorem that I showed you the other time, they found that the probability that Simpson K. Brown, given the evidence, was 0.72, which means that's very high, right? And they also find the probability that the drug dealer K. Brown, given the evidence, to be 0.29. Okay, that's very small, right? And they found the probability that the LAPD framed Simpson, giving the evidence, to be 0.99. That's too high. Okay, and this is the reason. Okay, this is actually the reason why Simpson was actually discharged and acquitted. Okay, take a look at that. But let me tell you this. That's why I don't pray to get him, to get involved in litigation, because even though you have your evidences, there's possibility that you are not likely, there's possibility that you are not likely to get, justice. You get what I mean? So because the fact remain that we don't expect the judge to be 100% perfect, you get what I mean? And none of, the people that get involved in litigation is 100% right. Okay, so take a look at that. Okay, I think I'm going to give this as an assignment. Take a look at the one I mentioned before. Okay, here, in a jury trial, suppose the probability the defendant is convicted, given guilty is 0.95. Okay, and the probability that the defendant is acquitted, given innocent, is 0.95. Okay, suppose that the 90% of all defendants are truly guilty. Okay, now take a look at that. If 90% of all defendants are truly guilty, which means 10% of them are truly innocent. Okay, now, and don't forget the conditional probability of 0.95 has been given here, where they say the probability of of the defendant is convicted, given guilty, is actually that. You can also trying to figure out, okay, what is basically going to be the probability that is being acquitted, given guilty. Okay, that would be 0.05 as well. What is the probability that is actually going to be convicted, given innocent? That's also going to be 0.05. And what they ask you to find out now is the probability. Oh my God, I'm actually going to give you the formula, but I need you to do that. Okay, it said find the probability that the defendant was actually innocent. Okay, you basically want to find the probability innocent, if I use I for innocent, given that is given the defendant is convicted, okay, and of course, if you want to use a Bayes theorem now, it's basically going to be the probability of C, okay, the probability that is actually being convicted, given innocent, multiply by the probability of innocence, and don't forget, you basically going to divide this by the total probability that actually called the probability that is actually going to be convicted. And you know what? That probability that is basically going to be convicted that I mentioned, you know, an accused person could get convicted, okay, based on two things, okay. It could be innocent and get convicted. You get what I mean? This is this guy here, multiplied by the probability of being innocent, okay? Or that is going to be a plus, right? Okay, so that is going to be the probability that is actually going to be convicted, you know, given guilty, okay? And that will be multiplied by the probability of guilty. Take a look at that. That's what I call the total probability. Or so you can take a look at that, and of course you'll be able to get the result. But let me tell you this: if your final answer, okay, to this question is actually 0.006, okay, if your final answer is actually 0.006, then you are definitely right. So which is going to be the probability of of the defendant is actually innocent, given that he is convicted. That probability is very, very small. Like I said, in the court of law, they are not perfect. They are human beings. Okay, they could make mistake as well. You get what I mean? They could make mistake as well. Okay, so this is where I'm actually going to stop today. Is there anyone who want to ask question or who need clarification? Okay, so in the absence of question, it means you guys are good. Make sure you stay safe and have a lovely day. See you next time. Bye, everyone.